Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Okay, so now that we have Unity open, we're going to make a very simple Unity project. In project name, we're going to type A star. Okay, that's simple. For the location, I like to have a projects folder that's right under my home folder, okay, whatever name you have in your computer, whether it's a Mac or a Windows, it doesn't matter. I'm going to disable Unity Analytics, that's not going to be necessary. And we're going to leave Unity in 3D. Even though it seems like it's more complex than two-dimensional, this is actually Unity in its most pure way. Okay, Unity started with 3D and then later added 2D, but we're going to start with 3D. After you make sure you have this selected, we're going to click Create Project and just sit back and wait for a few seconds before Unity is going to load. Okay, and we're going to build a few things here and there. Just make a few folders, a few files, and we're going to make sure everything is going to work. Okay, so in order for us to kind of work with the same Unity layout, it's interesting for us to go to the top right here, click on Layout, and select Default. Okay, it might not change anything in your Unity instance, but just in case you resized anything or moved the tab from one place to the other, just select Default again here, so Unity is going to reload with that layout here. Okay, so in the project window, we just have an assets folder here. Okay, so everything we make in this specific project is going to be here, but it's still interesting to make a folder here. So we're going to right click, create, and select folder and name this project. In the beginning, it seems like it doesn't make sense. Hey, we are working in our project and we're going to make a project folder. We already have an assets folder. Why do we do this? This is interesting because if you go to the asset store and you download a Unity package here, or you download something from the internet and you add here, third-party assets, by default, they are added in the assets folder. And some of these third-party assets, they might not have a good structure. Okay, maybe as soon as you add third-party assets here, it's going to add folders with names like scripts and scenes and animations, for example. And these folders might conflict with your project. But if you make a project folder, which is a pretty neutral name, okay, I don't think any asset in the world is going to have a folder called project in the root folder. You're going to make sure all your assets are going to be inside this folder. This is kind of your safe zone. Everything we make regarding this project needs to be here, okay, because that's something that we are going to control. Okay, it's our folder for this project. All right, and in this project folder, we're going to start with just a few basic folders. I'm going to right click, choose create, then I'm going to choose folder, and I'm going to name this scenes. Then I'm going to right click, choose create, folder, and I'm going to name this scripts. Okay, so we're going to have these two folders, right? And that's the basic folder setup for now. We might need to add some other folders later, but we're going to stick with this. If you look at the hierarchy, we just have one scene called Untitled. Okay, so that scene hasn't been saved. If you do something here and your computer happens to shut down or whatever happens, you're going to lose your scene. So just to begin, we're going to save this. So we're going to File, Save Scene. Okay, wait a little bit. And if you look here, I am in the Projects folder. We're going to the Assets folder, Project, Scenes. And I'm going to name this scene as, let's name this game. Okay, a very basic scene. So we're going to save. And if you look at the scenes folder, we have the game folder. Okay. Now, to execute the A star algorithm, we're going to have one game object in our hierarchy. That's going to be called A star. something really basic, because we're going to do a little bit of testing here. Okay, think of this project, this A-star project, as a huge sandbox where we're going to try things, experiment, add characters, visual elements, 3D elements that we can play with and make them go from place to place. Okay, so good. Now I'm going to right click in the hierarchy, choose create empty like this, and I'm going to rename this game object to A-star. Okay, and you might have guessed this A-star game object is going to have its own script. So we're going to the scripts folder. I'm going to right click here, choose create C# script, and I'm going to name this A-star. Okay, now we wait a few seconds for the code to be ready so it's compiled and fully processed. Now I'm going to select the A-star game object. Okay, make sure its position, rotation, and scale are all neutral. Okay, so that's 0 for position, 0 for rotation, and 1 for scale. And I'm going to drag this A-star script and drop here in the A-star game object. So it's going to be added as a component. Okay, notice that the game scene has an asterisk on its side, so we're going to go to File and hit Save Scene, just to make sure this game object is going to be saved. Okay, good. Now we're going to open the A-star script. If you double click it, you're going to wait a few seconds for MonoDevelop to open. Okay, something that already came installed with Unity. And after it opens, well, you're going to get used to this screen for a lot of time, because we're going to spend most of this initial lesson working with astar.cs. Okay, everything we make regarding this algorithm is going to be in this file. So we need to be a little bit patient. Okay, we're going to cover some lots of concepts here. Okay, but we will eventually get this right. Okay, don't worry. So now that we have this script ready, we're going to move on to the next lesson, where we're going to understand what are nodes and why do we need them in this algorithm. Alright, so here we go. Let's get to coding. Whenever you're working with a pathfinding algorithm, probably all of them are going to use a concept of nodes. Okay, there might be some different names depending on the literature, depending on which paper you are reading, which algorithm you're going to implement. But in general, nodes, they are some sort of object, they're some sort of structure that is going to hold the information of a certain position in the map. Okay, so for example, if you have a mountain, okay, let's go back to the strategy example I gave you a few minutes ago. If you are in a mountain and there is a left path and a right path, and the left one is dangerous, the node in the left is going to have some sort of information that's going to say, hey, this is dangerous. Okay, so there's going to be a higher cost for you to go through this path. Okay, and in the right side there's going to be another node that's going to say, hey, this is a pretty neutral way. You can go here, it's not going to cost you much. Okay, it's just going to be costing your troops time to travel from one place to another. Okay, it's basically a structure that's going to hold information in a certain position. And for this structure, we're not going to actually use the A-star class now. Okay, we're going to make a separate class in the same file. Okay, no need to create any new files. And we're going to put all of its information in this class. Okay, so we start by typing class node, and we open and close curly braces. Okay, so we made our own node class. Okay, to begin, and that's a very good practice for you whenever you're making games, even if it's new and you're working on a tutorial, or if you're experienced. It's interesting for you to explain even more if you're making an algorithm. So let's use human language. Let's add comments to our code. Okay, so I'm going to type here class that holds information about a certain position. Okay, so it's used in a pathfinding algorithm. Okay, that's pretty much it. Something really simple, just getting this out of my mind. There might be better ways to explain this, but it's the basic. Okay, just holding information for you. Now, for starters, whenever you're making a node, you need to understand that a node is going to have a position in the X value Okay, so that's the horizontal position, and it's going to have a position in the y value. That's the vertical position. Okay, so I'm going to add a public integer. Okay, so a number with no decimal part, pos x, and also public int pos y. These are the two positions to be used. So nodes have x and y positions. So that's horizontal and vertical. Okay, good. So we have these two variables. Now we're going to go to something a little bit more advanced about this algorithm. That's pretty much the most important part of this entire lesson. It's really important for you to pay attention to this, okay? Because the A* algorithm has two variables for scores. Okay, so what exactly is a score? A score is going to be a value. It's going to be a cost that the node is going to hold for you to go from a previous node to this one. Okay, it's a cost. Whenever you're talking about pathfinding, whenever you're talking about A* or several other algorithms to find paths for one way to another, you have to think about cost. Okay, for example, if you are on city A and you can go to city B or city C, there's going to be a cost for you to perform this operation, to perform this movement. If you go from city A to city B, that's 50 kilometers, okay, because, well, that's the distance. If you go from city A to city C, that's 20 kilometers. So the score from A to C is shorter from A to B, okay? So if you want to go to just another city, it's much better for you to go from A to C, okay, because of the cost. And in A*, we're going to have two different costs. We're going to have the G cost, so I'm going to type public int G and public int H, okay? So we're going to have these two scores to be used. Okay, so what is the G cost? This is going to be a very basic cost. It's the most basic one. It's the cost for you to go from one node to the other. Okay, so for example, let's say we are in the position 0, 0, 0 horizontally and 0 vertically. If you want to go from 0, 0 to 0, 1, that's a direct neighbor. So the G cost in that node, in the 1, 0 node, is going to be 1. Okay. Now, if you go to the other node, if you go to 2, 0, for example, 2 on X and 2 on Y, that node is going to hold the G score 2. If you go to 2, 1, that's moving up. So the cost of that new node is going to be 3. Okay, that's going to be something really basic, just a basic cost for you to go from one node to the other. Okay, so let's add a comment here. G is a basic cost. Okay, let's stress that out. Value to go from one node to another. Okay, and now we have the age score. Okay, but actually let's call this F, and you're going to understand soon why. Okay, so another important concept, and I need you to pay attention on this, is remember this word, heuristic. Okay, heuristic. I'm not sure if that's how you pronounce it in English, but basically heuristic is an estimate. Okay, it's not going to be a precise thing, as this is an estimate, but it's a good guess on the distance between two different places. Okay, so for example, when you're thinking about a map, okay, for example, a very basic matrix. Okay, we have the position 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, a very basic matrix. Okay, if you had to guess the distance between the bottom left point to the top right point, what would that distance be? Okay, a very basic heuristic that we use here is called the Manhattan distance. You're basically going to sum the horizontal distance with the vertical distance. Okay, it's a guess of how distance two nodes would be from each other. You could of course take a diagonal path. Okay, if you went diagonally, that would be less. You would have a lesser of a cost to do this. But if you don't have the diagonal movement available, okay, if you can only move horizontally or vertically, not two at the same time, you'd have to take a different guess. Okay, so guess is basically, the heuristic is going to be basically a guess from the cost from one place to the other. It might seem a bit foggy to understand this right now, but as we implement this algorithm, we're going to understand this. Okay, so even though we are calling this f, I'm still going to explain you that age is a heuristic that estimates, and that's our keyword here, the cost of the closest path. Okay, by closest path, I mean the closest path to go from point A to point B. You're going to understand this as we make this. Okay, so we have G and we have F, the two costs. Okay, now we're going to need another thing in the node. Okay, and this is pretty interesting. I'm going to add here a public node parent. Okay, so wait a second, why parent? And why are we going to reference another node? You have to understand that nodes, they're not things that are going to exist at all times in your game. Nodes, in this specific case, the way we're learning here, they're only going to exist for one single purpose: execute the algorithm. Okay, we just want to execute an algorithm to get a path. Okay, imagine we have a huge map, we have a huge scene. If you are piloting a tank, for example, and you want to go from position 00 to 150 to 100, you don't have to keep track of thousands of nodes. You want to create all of those nodes, but everything you want to have is a path. Okay, it's a link between every path, every place the tank has to move to reach its destination. Okay, and to do this, for us to have that link between point A to B, B to C, C to D, and finally D to destination, you need to have a variable that holds a reference to another node, and this we're going to call a parent node. Okay, so let's type in here a comment. Nodes have references to other nodes, so it is possible to build, let's say here, a path. Okay, so if you select one node and just keep following all of the parents, you're going to eventually go from the origin towards the destination. Okay, now a node needs a value. Okay, and the value is going to be important for you to understand, for example, if a path is dangerous or if a path is going to have treasures. Okay, nodes should be able to hold some sort of information. So to do this for the node class, we need to have a list of all the possible values for a node. So because of this, we're going to the top of the node here, and we're going to make an enum. Okay, I'm going to type public enum value and open and close curly braces. Okay, and for this example that we're making here, we're going to have only two different values. Free is the first one, it's the basic one. It basically tells you, hey, you can go to this node. And I'm going to have another node called blocked. That means you can't go here. It might be lava, it might be a hole, you just can't step in this node. Okay, so let's add a little comment here. Basically, we're going to say every node may have different values. Okay, let's values according to your game application. It really depends on what you're building. Okay, so now that we made this enum here, let's move down a little bit. Okay, below the line where we declared the parent, and now we're going to type public value with an uppercase V to reference our enum, and then value, which is going to be the name of this variable. Okay, that's just the value of the node. Okay, that's all we need to do. Okay, so now we have an enum to declare the value, we have the position of this node, X and Y, we have the G cost, we have the F cost. Okay, that's going to hold a heuristic value, and you're going to see that soon. All right. We have a parent, so we can reference the node that's going to move from that node to this one, the current one. We have the value here. It's going to hold if it's going to be a free or a blocked node. So finally, what we have to do is add a constructor. Okay, so let's add a comment here, constructor. And to make a node, to be honest, we just need two things. We just need its position. So I'm going to add here public node, and the parameters are going to be int pos x and int pos y. Okay, so to start, we're going to initialize the position. So this dot pos x is going to be pos x. So whatever we pass here is going to be saved here internally. And now this dot pos y is going to be pos y. So whatever we pass here is going to be saved there. Okay, and finally, to initialize the value, we're going to say that value is going to be value with an uppercase V dot free. Okay, so that's basically it for this class. We're going to save this. Let's go to Unity to allow the code to compile, and it's interesting for you to do that from time to time. So whenever you have any mistakes, you can see if anything wrong is going to happen here. Okay, so we had some errors here, but that's just basically things about internet connection. Don't worry about this. But if I force another save, you're going to see that we're going to have a few warnings here. Okay, these are not going to block your game from executing. It's basically telling you that G and F are never assigned. They're going to have default values, in this case 0, and parent, since it was never assigned, it's going to have its value null. So if you want to make these things specific, you could start them here like this. Okay, G equals to 0, F equals to 0, and parent equals to null. Or you could start them in the constructor. Okay, it's really up to you to choose how you want to initialize these things, but let's do it that way, just so we don't need to add any unnecessary lines. Okay, so we save this, go to Unity, wait for the code to compile, and we have no warnings or no errors. So that basically means we have a green light to move on to the next lessons, where we will start to put all of these things into use. Okay, but we have to make some linkage between the nodes and the actual algorithm execution. So we need to build a map. Okay, we're going to do this in the next video. Okay, so right now we're going to build a map. For this specific example, we're not going to use Unity. We're not going to use any 3D assets, we're not going to use lights, any features from the Unity engine. We want to make sure we're going to stick with something that's as low level as possible. So we're going to play with strings a little bit. Okay, we're going to use some characters to represent a certain fictional map where our tank or character, for example, is going to move to, and we're going to need to find a path from one place to the other. So to do this, we're going to need some variables. Okay, we're going to need some fields here in the A star class. So make sure you move to this class for now. Okay, I'm going to take off these. No, let's keep them here. Okay, so first we're going to start by adding a constant here. So let's add a constant comment, and I'm going to say private const int. And the name of this integer value is going to be map underscore size, and I'm going to initialize it with 6. Okay, the map that we're building here is going to be squared, so the number of coordinates in the x axis, so in the horizontal axis, is going to be the same in the y-axis. So the map size 6 means that our map is going to have a 6 by 6 size. If you use 10, it will be 10 by 10, and so on. But we're going to make 6. We want a very small map. Okay, so that's the only constant we need here. I'm also going to add some variables. Okay, and for this specific example that we're making to learn the A-star algorithm, we need just 2 variables. First of all, I need a list of strings. Okay, so you put string between the lesser than and greater than signs, and the name of this variable is going to be map. okay? But notice something. This map that you see here is going to be something that it's going to be really basic, just for you to see how the map is going to look like, okay? And let's make that map private, okay? No need to change it to something else. And now we're going to make a private node. This node is going to be an array like this, and more specifically, it's going to be a bidimensional array. So you add a comma here, okay? It's basically telling you that you have two different coordinates for this array, okay? And I'm going to name this node map. This is the most important thing, the most important variable that we have here. So the classes that we created here at the top, okay, this single class here is going to be used lots of times. More specifically, it's going to be used 36 times, okay? This node array here is going to have 6 horizontal places and 6 vertical places because of the map size, okay? So it's going to hold 36 nodes in a single variable. So it's going to be really easy for us to visualize and to navigate in this node map here, okay? So let's do this in a very straightforward way. First of all, we need to initialize our map, more specifically our string map. So I'm going to say that map is going to be a new list of string, okay? And as we are building this list, as we're calling its constructor, we need to open and close parentheses. No parameters necessary here, okay? And now, since this is going to be a 6x6 map, we need to make sure that every string that we add here is going to have 6 different characters. So I'm going to type map.add, open and close parentheses, and add a semicolon. I'm going to open and close double quotes, and I'm going to add 6 dashes. 1, 2, 3, 4, 5, 6. Okay, like this. Now I'm going to copy this line and paste it 5 times below. So now you have 6 instructions called map.add. Okay, this is going to be our map. So the interesting thing about visualizing this is because it's going to be easy for you to understand how to go from one place to the other, because in the case of monodevelop, and to be honest, I think all development interfaces, the font that we see here in mono is monospaced. Okay, so whatever character you add here is going to pretty much occupy the same space. Okay, so this one, F, W, or the hashtag, for example, is going to occupy the same space. It's different when you're writing a document where things tend to go out of place. But in general, this is going to be make our lives really easier so we can visualize a map. Okay, so what we could do here is switch these dashes for X's whenever we want to have a wall. So I'm doing something like this. Okay, I'm going to add some walls here, and let's do it like, no, let's use a dash here and an X here. Okay, so we're basically adding walls, and we want to add a start position and a goal position. So I'm going to add an S here. This is going to be our starting position. So we imagine our character is going to spawn in this position, and our goal is going to be here. Okay, so our character has to go from here to here. So a dumb algorithm would basically make our character go from this place here, and then move here, and then move here. But that's invalid because we have a wall. So a dumb algorithm would basically mean this guy would never reach G. Okay, a smart algorithm would make this character move down and then right, and maybe a dumb algorithm would try to make the player move up, but that's also an invalid path because there is a wall here in the end. So the player has to move down, go all the way right, all the way to the top, and finally all the way to the goal position. Okay, so that's something you have to keep in mind. If you were to close this path, the player would never reach this goal, this final position. You need to make sure you have an open path so you can actually reach your goal. And once we're finished with the algorithm, we're going to experiment with different layouts. Okay, So that's basically what we need to do to make this string map. And also, before we even jump into the A star algorithm, we need to actually parse this map. Okay, this is just a representation for us on how the map is going to look like. It could look like this. Okay, it's a string. We could use Unity. Okay, we could place blocks here in different positions, but in the end, everything needs to be translated into the node map. Okay, it's the most important thing that we're using here. So you could even use another technique, another algorithm to build a map, but in the end, you need to use the node map. Okay, so we need to parse the map. Okay, so first of all, we're going to initialize our node map. I'm going to type here node map equals to a new node. Let's open brackets, add a comma and close it, and then a semicolon. And since this is a bidimensional array, we need to specify the size in x and y. That's going to be map underscore size for x and map underscore size for y, or for dimension 0 and dimension 1, to speak more correctly with bidimensional arrays. Okay. So we also need two important nodes, okay? From all nodes that we make here, the most important ones are the start node, which is this one, and the goal node, which is this one. So I'm going to type here node start, and we're going to initialize it with null, and node goal, which we're also going to initialize with the value null, okay? So now, finally, we have to actually parse our map. So we're going to make a loop here where we're going to look on all the characters that we have in our map. Okay, so this is what we're going to do. We're going to type for int y equals to 0, while y is lesser than map.count y plus plus. Okay, so this y here is basically going to choose which line of this list we're going to read. Okay, this is line 0 and then 1, 2, etc. until we reach map.count minus 1. Okay, basically iterate over all the strings we have here. Inside y, we're going to add for int x equals to 0, while x is lesser than map underscore size x plus plus. We could do this differently, okay? Instead of using map count here on y, we could also use map underscore size if you want to keep things consistent, okay, using the same technique. Just make sure you actually use the exact size here, okay? So we have y, we have x internally, and now finally we can create the nodes, okay? So I'm going to type node, okay? It's going to be a new node. And we pass x and y as parameters. So in the beginning we have 0, 0, then 0, then 1, 0, 2, 0, all the way to 5, 0. Okay, and then 0, 1, 1, 1, 2, 1, 3, 1. We're basically building a map like this. You can visualize this node map exactly as you see here. Okay, between this double quote and this double quote. Okay. And not only you should create in the node, you need to save it in the node map, of course. So we're going to type node map, and the node map in the coordinates x and y, this is going to store our newly created node. Okay, but we still have one thing missing here. We created our node, we stored it, but we're just holding the node's position, x and y. We have to remember that every node that we create here is going to have a value. It could either be free or blocked. So we need to look at the character that we have here and change its value to blocked if we are looking at an x. Okay, so here I'm going to put it in the middle, and we need to look at the current character that we are looking at. So I'm going to type char, current char is going to be, and then I'm going to type map. I'm going to look at the coordinate y, okay, because we're looking at one of these here. Okay, it could be y0, y1, y2, okay. So that's going to be, we're selecting the string from the list of strings, and then after I do this, I'm going to put an x between brackets as well, because now we're selecting a character in this string. Okay, so we're going to be reading the char. It starts like this, and then read this one, and then this one, this one, this one, this one. Then it's going to go down and read every character like this. Okay, you have to visualize the algorithm actually executing it like this. Okay, so we are saving every character that we're looking, and then basically we have to type if current char equals, so two equal signs to uppercase X between simple quotes like this. If this is true, then we're going to say that node.value is going to be node.value with an uppercase V, because we're looking at the enum, dot blocked. Okay, that's what we need to see if a certain character is being blocked. So we're almost done here. Since we're talking about parsing the characters, there are two that we still need. We need to save the start and the goal. Okay, and make sure that whenever you build this map, you have one G, one S. Not less, not more, exactly one of each. Okay, so we're going to read them. Okay, if a character has X, it's blocked. Else, if it's not X, let's see if it's a G. So else, if current char equals to the character G, that means we're looking at the goal node. So we type goal equals to node. However, if it's not a G, we still need to see if we're looking at an S character. So else, if current char equals to the character S, then we're going to say that start equals to node. Okay, so we're going to save blocked nodes. We're going to save the goal node here and the start node here as well. Okay, so we're going to save this. And after this is complete, we're going to Unity. Okay, let's just allow the code to be compiled. Just wait for a few seconds. And after we're done with this, notice that we have two warnings. It says that the variable start is assigned, but the value is never used. Same goes for the goal value, but that's fine because we're just getting started. Okay, we just made a string map and we are parsing the map here, okay, to build all the nodes. But now that we have this built, now that we have this in place, we can actually execute the A* algorithm. Okay, so don't worry, these are going to be used. Now, even though we built this map, before we even execute the A* algorithm, we want to do something different here. Okay, we just want to print our map. Okay, so I'm going to add here a comment, and I'm going to say print the map. Okay, this is going to be pretty simple. We just want to use Unity's console to see the map that we just built. Okay, so I'm going to add print the map, the comment here. I'm going to add string, map string, and I'm going to say that's an empty string, so you just open and close double quotes. And then I'm going to say that for each string that I'm going to call map row in map, okay, so you're basically iterating over every string you have here in the map, okay, all of these 6 strings, and I'm going to say that map string plus equal map row plus the \n character, okay, which is basically a new line character. Okay, and after you do this, in the end, we're going to type debug.log map string between parentheses like this. Okay, so we're going to save this. Let's go to Unity. We're going to wait for the code to compile. So make sure if you look at the A* game object, you have the A* script. Okay, now we're going to press play just to make sure everything that's here in the hierarchy is going to be executed. And if you look at the console, okay, I'm just going to move this up a little bit, you're going to see the map that we built in Unity. Okay, G at top left, S in the middle, and all the walls that we built here. Okay, so what is our goal here? Now that we have a very basic map, a string map, here in the middle, we're going to create our A* algorithm. So we're actually going to get the path from the start to the goal nodes. We're going to draw the path in the map string, and then finally we're going to see our path here when we print it. Okay, so right now we're going to save the script. Okay, in Unity there's nothing to be saved, so we basically move on to the next video.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.